All right, we are going to work a couple more examples on solving logarithmic equations. This first two, we're going to work our type 1, where a log is equal to log. So our first step is to condense the logs. And so here I have that 1/3 on the outside, so that tells me I'm going to use my exponential property. So I can rewrite this as log base 5 of 64 to the 1/3 power. And remember, that's the same thing as the cubed root, is equal to. And because I have these two added together on my right-hand side, log base 5 of 8 plus log base 5 of p, that is our product property. So I can rewrite this as log base 5 of 8 times p, which is 8p. Okay. So now I can use my 1-to-1 property and set my insides equal to each other. And the cubed root of 64 is 4. So 4 is equal to 8p. I divide by 8 on both sides, and I get that p is equal to 1/2. And then remember, we want to check and make sure that's not going to give us a negative number or a 0. And if I plug in 1/2 for p, it's just going to stay 1/2. So this is a solution. That takes care of number 6. Let's look at number 8. Log base 2 of 2x plus log base 2 of x minus 7. So I'm going to condense this, and this is my product property. So I can rewrite this as 2x times x minus 7 equal to log base 2 of 4x. So I can set these two equal to each other with my 1-to-1 property. And then I'm going to need to distribute that 2x to the x and the minus 7. And I'll get 2x squared minus 14x is equal to 4x. So then I want to move my 4x to the other side. And I'll get that 2x squared minus 18x is equal to 0. And then I need to factor. So if I factor this, make some room at the top, I can pull out my greatest common factor, and my greatest common factor between 2x squared and 18x is 2x, and that leaves me with x minus 9. So again, we solve this by setting both pieces equal to 0 and then solving. And so if 2x equals 0, then x is equal to 0, and if x minus 9 is equal to 0, then x is equal to 9. And then remember, I can't have a negative or a 0 inside, so if I plug in 0 for x, to 2x, that would give me a 0, or if I plugged it into 4x, that would give me a 0. So x equals 0 is not a possible solution, so our only answer is x equals 9. So that is our type 1, where log is equal to log. Now we're going to work to where log is equal to a number. So looking at number 12, first I need to get all of my log on one side and my constants on the other side. So I'm going to move this 15 over before I do anything else. So log base 8 of 28k minus 20 is equal to 3. So now I need to rewrite this in exponential form. So 8 to the 3rd power is equal to 28k minus 20. Well, 8 to the 3rd power is 512. 28k minus 20. I'm going to move that 20 over, and I'm going to get that 28k is equal to 532. And then I'm going to divide, and I'm going to get that k is equal to 19. And if I plug 19 back into k into my original equation, I'm not going to get a negative or a 0, so 19 is my answer. Now let's do number 14. First, I want to consolidate. I'm adding these two, so that means I'm going to use my product property. So 4 times c minus 9 is equal to 5. Rewrite it in exponential form, and I'm going to go ahead and distribute that 4, and I'll get 4c minus 36. 2 to the 5th power is 32. So now it's just some algebra. I add that 36, and I'm going to get that 68 is equal to 4c. Divide by 4, and I'll get that c is equal to 17. And again, if I were to plug 17 back into c, I would not get a negative or a 0, so 17 is my solution.